Alright, we're here at go-to-math.com. Let's click on calculus and then move on down to related rates. 9-1, I believe, is what we just got through doing. Wasn't it? Oh, 9 yeah, so we're doing 9-2. There's three of these problems in here. Come on, 9-2, there it is. Find the rate of change of the distance between the origin and a moving point on the graph of. Okay, so this is just similar to 9-1. So let me sketch down some numbers here. If you worked at 9-1, and you probably shouldn't have any problems getting this. dt is equal to 5. And we're trying to find the rate of change of the distance. Okay, so let's move over to the whiteboard. Wait a minute, I want to make sure my number's right. 2x squared, x equals 3, and 5 centimeters. All right. Looks good. Okay, so we're going to start with y is equal to. So hopefully you watched 9-1. So I don't think I'm going to go through all those things like I did. 9-1 in this problem. We're just going to work the problem. 3 centimeters, and then dx over dt is equal to 5. And of course, we probably just want to go ahead and write our, this is centimeters, provide our units in. Okay, so the first thing we're going to do, step 1, let's just go ahead and write this out. X of 2 minus x of 1, this is the distance formula, and y of 2 minus y of 1. Right. So we're going to need to know all our ordered pairs first off. We'll just write it right here. X of 1 and y of 1 is at the origin, right? It's set at the origin. And then x of 2 and y of 2, well, they gave us 3. Okay. And then, of course, y of 2, we're going to take this 3, plug it in over here. And 3 squared is 9, and 9 times 2 is 18. Right? 3 squared is 9, 9 is 18. Okay, so we've got that. Well, we're going to need some other things. What about dx over dt? We got that. Dy over dt, we're going to need that. So I'm going to go ahead and write y is equal to 2x squared, and then take the derivative. Dy over dt is equal to 4x times dx over dt. So we are going to need to know that. I mean, we just might as well get this out of the way. So dy over dt is equal to 4. Our x value is 3. And then our dx over dt, you can't see it on the screen, but if it was 5. Okay. So what do we have? We've got 3 times 5 is 15 times 4 is 30 is 60, right? 12 times 5 is 60. So our dy over dt is 60, and that would be centimeters per second. Okay, I think we got everything. Got everything we need. Let's go ahead and take the derivative of this. So this is 2d dd over dt, and then this becomes 2x of 2 minus x of 1, and then this is dx over dt plus 2 y of 2 minus y of 1, and that's times dy over dt. And if you multiply through by a half all the way across, that gets rid of this 2. Alright. And what else? So let's just go ahead and start plugging everything in that we know up to this point. So x of 2 is 3. x of 1 is 0. We could actually skip that step if we wanted to. dx over dt, they gave us that. That was 5 plus y of 2. That's going to be 18 minus 0. And dy over dt, which we got down here, was 60. Right? 60. 12 and 5 is 60. Okay. Let's just go ahead and do the calculations on that real quick. So that's going to be 3 times 5 is 15. Let's see, plus, and then 18 times 60. Whoa, that's a big number. So that whole thing is 1095. So this is 1095 over, and of course we take the d diagonally down. Remember, that's the distance, and that distance is equal to, and we're just going to be using these numbers here because the zeros are going to cancel out, right? It'd be the same exact stuff right here written down here. So this becomes 3 squared plus, as you can see, 18 squared dd over dt, and then we'll write the approximated value down here. Whoops, we're going to do some squigglies, and let's get that. So that's divided by the square root of 9 plus 18 squared. And man, we got a big number on that. That thing's moving, isn't it? Moving along. Sure hope there's no problems going on here. We get 60.00. Whoa, 60.0. I think this is probably going to be a 1 right here. And remember, this is centimeters per second. Okay, it says 0056, so I got a feeling this should be a 1. Probably. Let's see what happens here. Yep. So 60.01 centimeters per second. Alright. It's not too bad. You need to come on over and practice. These are typical problems to see on a test or in homework, one of the two. You know where you're at, and maybe I'll see you there. Bye.